Now I'm taking a short break from my place while I finalise the details of the design for the next project. So today I'm working over at a friend's house and we're going to turn this timber into this raised vegetable garden. The idea here is to make it as quickly and as efficiently as we possibly can. So let's get this timber unloaded and get started.
The raised beds are going to be constructed inside this old chicken coop, and the design is based around these varying height boxes, which should look something a bit like this when it's complete. Now if we strip away the existing structure, the raised planter, the chicken coop itself, we're left with the structure that we need to construct. So all stripped back, you can see it's a skeleton framework of timber. It'll be constructed by making up these frames for the end of each of the planters, and then they'll be connected using these rails. And to give maximum strength, I'm going to use half-lap joints to construct those end frames. And the first job is to cut all that timber up into the parts I'll need to make all of the frames and all of the rails. Now I spent a few minutes just sketching out all of the parts based on the computer model I created, so I've got a reference as I'm making all of these frames. This way I limit the chance of any mistakes during the construction. It also means I don't need to do any calculations, and I've created this cutting list that you see here. Now this is really handy because it allows me to keep a tally on all the parts that I need, but also all the ones I've made. I'm using CCA treated timber here, and the sawdust is potentially quite harmful if you were to inhale it. And so, although I'm working outdoors, I did decide that there was just too much sawdust, and connecting up an extractor, a vacuum cleaner, would be the way to go. And as you can see, this does a great job of taking away all of those airborne particles. This design is very much about repetition, so using that cutting list and just setting up a production line and getting all of the parts ready to go.
Now I need to join all of these parts together to create these frames, and all of the joins are going to be a half lap. Got two offcuts here. Just going to line this up. I'm doing a quick test to see if the saw can cut this half lap joint. So what I want to do is remove all of this material, half the thickness, on both pieces, and then they'll lap over each other, forming a really tight and flush join. Now there are a lot of parts that need to be half lapped, and so I'm certainly not going to be marking out every single one. Just going to mark this one out so I can run it through the saw and see if it works. So here's the piece of material we've just marked out. It's got the area that we want to remove, and so if I engage this, you can see that currently it stops a little bit high, so it's not going to cut deeply enough. Now if I rotate this in this direction, clockwise, it will raise the blade, limiting the stop. So if I turn it anti-clockwise, I can bring that all the way down to my mark. Now that's about right. I'm going to do a test cut, see how good that is. You can see, we can still actually see the pen mark there. I'm going to go a little bit deeper. Good, so that looks about right. I won't know until I test it on another piece and put them together to see how well they fit. However, you can see there's an issue here. It's not cutting all the way to the back, and that's of course because of the diameter of the blade. The solution is to space this away from the fence. I'm going to put a scrap piece of material in here, and that way it'll be able to cut full depth. Okay, now if that depth has been set correctly, these two will be perfectly flush. You can actually see sitting up about 1.5 mil, about 1/16, so we need to cut just a little bit deeper. Perfect. So I've got my depth set and I've got my mark here on this backer board, just showing where the first cut should be made.
And there we are, a nice perfect fitting half-lap joint. There are many different ways in which you could cut these half laps. Now I'm using the miter saw because, well, I've just bought it second hand and why not? First opportunity to try it out and I'm actually really pleased with how accurate this saw is. But you'd get equally good results just using a handsaw and a chisel, or even a handheld circular saw with the depth of cut set.
Well, now I've cut all of the half laps on those horizontal pieces. They were very straightforward, exactly the same on both ends. Now I've got to contend with the slightly more complex vertical pieces. Now, each of these frames which I've laid out here are different to each other. They've got a half lap on the top, but then they have a cross rail at a different height. They're all quite different to each other. That just means a little bit more thought. I can't just plough ahead. I've got to actually measure out each of these frames. There are 13 frames in total, and make sure that the half lap joints are in the right place. Number 2, I need a couple of 620s and a couple of 650s. Get those on the table, make a plan on how I'm going to actually cut these, and then I can just run through all of these quite quickly, relatively quickly. Okay, it won't be quickly at all, but at least I'll have a plan. So it's this material I need to remove. Nice. Beautiful. There we go, frame number 2.
So it's back to the production line and get all of the half laps cut, ready for these frames to be finally assembled. I'm gluing these together with some exterior grade PVA glue, making sure to get an even coating of glue, particularly on those shoulders. Now, making sure you glue the shoulders will almost double the glue surface area, really increasing the strength of the join. The nature of the half-lap joint pulls all the components square, but it's worth just double checking now and again before driving in some screws just to clamp it together while the glue sets up. We need a good coating of glue, so no dry spots, but not so much that when it gets clamped together, lots of glue oozes out. That's wasteful. But more importantly, glue itself isn't very strong. It gets its strength by absorbing into the wood fibres, creating a strong bond, but it does require that the parts are close fitting.
So that's all the frames glued and screwed together. They're almost ready to assemble. They've got these rails that are going to be spanning between each of the frames. Short rail here, short rail here, short rail here, and so on. But at the bottom, the rail is going to be continuous, running the entire length, tying it all together. And so it just needs a notch taking out here, this material here, front and back, 100 by 50, 4 inches by 2 inches, so that that continuous rail can run right the way through, maintaining that flush finish. And to do that, I'm taking an offcut of the material here, laying it flush with the underside of the frame, flush with the side of the frame, and then just tracing around the outline, like so. There's the material I need to remove, and if I stay just inside the black pen mark, leaving the pen mark in place, I know it'll be exactly the right size. To remove this excess material, this notch that I need to take out of here, because it's quite thick material and it's still wet, I'm going to use the circular saw to make most of the cut, and then the jigsaw just to finish off. Because it's wet timber, it's going to be that much harder work.
It is quite easy to get disheartened at this stage of a project when you've spent so long just cutting up and shaping timber and actually got nothing to show in terms of where the construction is supposed to be taking place. But all this planning and prep really is worth it, and it certainly makes the job more efficient.
So now I get to find out if my dimensions, my measurements were actually right. I built all of these frames to the drawings that I created based on the computer model that I did, and I've not double checked those things. And why would you? The computer never lies. This is the first opportunity to get those frames into this area and see if it all goes together, if this jigsaw puzzle really fits. Now, to fix all of this together, I'm using these lag screws, landscaping screws. They've got a large diameter flat head, so they've got good holding power, and these are coated, so they can be used in an outdoor situation such as this. But more importantly, the coating will resist the attack of the chemicals in the pressure-treated wood. If I were to use a standard steel or galvanized, they would get attacked by the chemicals, and so these are going to actually stand the test of time.
I soon realised that the first two frames, the end frames, were going to be quite difficult to install because I'm working within the confines of this existing old chicken coop. So it meant attaching the screws from outside the chicken coop, working through the mesh. But the more challenging problem was how to attach the rails to that end frame. I need to hold the rail in place, but also need to attach the screws from outside the chicken coop. But I found strapping it together and tying it off to the mesh roof held it in place firmly enough for me to be able to put the screws in.
So just to avoid any confusion, I've numbered up my frames and I've already marked out the positioning of where each frame fits on these front and back rails. That way, everything lines up beautifully. Shouldn't need to do a whole heap of measuring.
Well, one side finished, all I need to do now is repeat that entire process for the other side. But of course, it goes much more quickly once you've actually got your process sorted. And the final stage of constructing this skeleton framework is to make this rather large interconnecting planter. And really simple construction. It's just made of 4 pieces of timber screwed together to create this frame, which is going to be in the base of the planter. And then an identical framework manufactured for the top of the planter. Well, that's it, a good day's work and a milestone reached. Time to pack away and come back tomorrow to finish off.
Well, now the timber frame is complete, it's time to clad that with something that can actually retain the soil. And I've got this pile of roofing iron. It's actually been used as fencing in the past. I've purchased it just as a recycled material, and it's got this really nice rustic patina to it. It's actually not that rusty, it's pretty good condition. It's a trapezoid profile, as you can see here, and I think this is going to look really quite nice put vertically into that timber frame. So I can use that one as a template just to mark off on all the other pieces I need. Nice and quick and easy, no measurements required. But I don't know if I've got enough of this tin to actually finish the job, and so I need to be as economical as I possibly can. So I'm going to take a measurement of this offcut and see if that will fit anywhere else before I chop this up into a small piece and a useless piece. So we've got 1085. Okay, now this is quite dented here, so I don't mind a little bit of wastage, and this is actually enough for a 650 wide piece plus a 400 piece, which is for my shortest planter.
And here are the screws I'm going to be using to attach the steel to the timber frame. You can see it's actually a roofing screw. Got a nice coarse thread, large diameter washer style head, hexagon, so nice and easy to install without rounding those over. And on the tip here you can see it's got this groove cut, that's so it's a self-drilling hole. So I don't need to worry about drilling through the steel first. These, with enough force with the impact driver, should drive those straight through the steel and into the timber. Now I'm not concerned about this slight mismatch in the overlap, and I'm not concerned about the sharpness of this edge. This is going to get capped off with some timber just to finish it off and make it look good, but also protect the users from this edge here. Okay, so now I'm happy things are actually working out. I'm going to cut 3 sheets at once. That'll get me all of my longest pieces.
So I've got this collection of fence palings which I'm going to be using for capping off the top of the planters. I've got all of my measurements here that I've just taken from the planters. I'm going to work through this pile and see if I've got enough to make all of these frames. So first job is to square off one end, take a measurement and cut it, and then I'll plane the edges to make them nice and smooth. And just taking the small block plane just to knock off those corners, make it look nicer but also reduce the chance of splinters. Now I think you can make out quite a lot of these fence palings are actually quite cupped. You can see this one is cupped this way, so it's crowning on this face here. So I'm going to be using that as the top face, and that way any water that runs onto here, and it will, remember this is a plant, it's going to get watered, water can run off to the sides. If I were to put it on this way, it naturally wants to cup in this direction. We'll have water sitting down the center. That's not great for the timber. Now I'm choosing to line the inside of these planters before I put soil in them with this plastic. This is 100 micron plastic, just about thick enough really. And there's a couple of reasons why I'm choosing to do this lining. The first one is that this timber is treated. It has to be because this is an outdoor product, it's going to get very wet. Now in New Zealand we still use CCA treatment. Copper and arsenic. Now those are the sorts of things you don't really want leaching into your vegetables. So forming a barrier between the timber and the soil is important. The other reason, of course, is that this is recycled roofing iron, and this has got paint on it, and there's a good chance that that has a lead content, being quite old paint. Again, you don't want that leaching into the soil. And the final reason is that this tin will rust out given some time. This will provide a barrier for the moisture and help this last a whole lot longer. Now, I'm not lining the base of these planters. I do want the soil to be free draining. Just need to protect the soil from the planter itself. And to hold the plastic in place, of course the soil will hold the plastic in place, but in the meantime, to hold it in place while this gets filled up, I'm just going to wrap it over the top like you see here, and then put the top capping trim in place. That will screw it all together.
Well, I was tempted to miter the corner of these capping rails, but in reality this is going to get watered quite frequently, and that moisture is going to cause the timber to expand and contract, and that could cause the joint to open up and look uneven. So having these butt joints allows that timber to expand and contract without affecting the aesthetics. Now to dress the area up, get some weed mat down to help suppress any future weed growth, then coat it with 50mm, about 2 inches thickness of a 20mm river pebble. Now this has been chosen because it's nice and smooth, easy on the feet, sounds great, and it's very cost effective.
Well, there's all the finishing touches put in place, so come and see what it looks like right now.
It's been great also to be able to use some recycled materials such as the roofing iron and the fence palings, and even some old electrical wire used to make these chains to hang the labels from. Well, it turned out even better than I could have imagined, and the homeowner's really pleased with it to the point she's even got it planted up.
Well, this has been a really fun project. You know, something that started out as just some boxes to grow vegetables has turned into this really good looking vegetable plot. Now, I hope this has inspired you to get out and grow your own vegetables and maybe even build your own planters. Now, I'm looking forward to getting back into my place next week and starting a nice big project, so I do hope you'll join me for that. But that's it for now. Thanks so much for watching. Bye.